DNS Fundamentals. Module Overview. The Domain Name System, DNS, is one of the most important services on any IP network. It acts as the Internet's phone book, translating easy-to-remember domain names into IP addresses that computers use for communication. Without DNS, users would need to memorize numerical IP addresses for every website and service they access. Example: instead of typing 142.250.190.78, you type www.google.com. DNS performs the translation behind the scenes. Learning objectives. By the end of this module, you should be able to explain the purpose of DNS, describe how DNS name resolution works, identify the different DNS server roles, understand the DNS hierarchy, differentiate common DNS record types, explain forward and reverse lookup zones, distinguish recursive and authoritative DNS servers. What is DNS? DNS, Domain Name System, is a distributed database that translates host names, domain names, into IP addresses. Definition: DNS is a hierarchical naming system used to resolve human-readable domain names into machine-readable IP addresses. Example: www.microsoft.com maps to 20.112.xxx. Without DNS, user arrow must remember IP address. With DNS, user arrow types domain name. DNS arrow finds IP address. Computer arrow connects automatically. Why is DNS important? DNS provides 1. Easy name resolution. Humans remember names easier than numbers. Example: www.facebook.com. Instead of 157.240.1111.2222. 2. Faster communication. Applications automatically locate servers without manual IP configuration. 3. Scalability. Millions of websites can be organized efficiently using the hierarchical naming system. 4. Flexibility. If a server's IP changes, only the DNS record needs updating no every user's device. 5. Supports many Internet services. DNS is used for web browsing, email delivery, Active Directory, cloud services, VoIP, gaming, streaming, VPNs. How DNS resolution works. DNS resolution is the process of finding an IP address for a domain name. Suppose a user types www.google.com. The process follows these steps. Step 1. The browser checks its own cache. If found, done. If not, continue. Step 2. The operating system checks its DNS cache. If found, done. If not, continue. Step 3. The request goes to the configured DNS resolver, usually provided by ISP, organization, Google DNS, Cloudflare DNS. Step 4. The recursive DNS server checks its cache. If cached, returns answer. Otherwise, starts querying the Internet. Step 5. Recursive server contacts a root DNS server. Root server replies, "I don't know Google, but ask the .com servers." Step 6. Recursive server contacts the .com TLD server. Reply, "Ask Google's authoritative server." Step 7. Recursive server contacts Google's authoritative DNS server. Reply, www.google.com. Maps to 142.1111.1111.2222. Step 8. Recursive server sends the IP back to the computer. Step 9. Browser connects to the web server. Website loads. DNS query flow diagram. User. 2. Browser cache. 2. Operating system cache. 2. Recursive DNS server. 2. Root server. 2. TLDserver.com. 2. Authoritative DNS server. Returns IP address. Then. Browser opens website. DNS hierarchy. DNS is organized like an upside-down tree. Root DNS servers is at the highest level of DNS. Its purpose is to direct requests to the correct top-level domain. There are 13 logical root server systems operated by organizations worldwide, distributed through hundreds of Anycast instances for resilience and performance. Top-level domains, TLDs, is the second level. Examples: .com, .org, .net, .edu, .gov, .k, .uk. Its purpose is to know which authoritative servers manage domains beneath them. Authoritative DNS servers store the actual DNS records. Example: google.com. A record: 142.xxx.xxx. They give the final answer. Recursive DNS servers is used by clients. They perform all DNS lookups on behalf of users. Examples: Google DNS 8.8.8.8, Cloudflare 1.1.1.1, ISP DNS. DNS record types. A DNS record stores specific information about a domain. A record, host record. Maps. Host name. 2. IPv4 address. Example: www.company.com. Map to 192.168.1.10. Most common DNS record. AAA record. Maps. Host name. 2. IPv6 address. Example: www.company.com. Map to 2001 DB 810. AAA record is used for IPv6 addresses. Name record, canonical name. Creates an alias. Example: ftp.company.com. Pointing to www.company.com. Both point to the same server. Useful when multiple names should reference one host. MX record, mail exchange. Specifies the email server responsible for receiving mail. Example: company.com. Receives mail from mail.company.com. Email systems use MX records to route messages. NS record, name server. Identifies which DNS servers are authoritative for a zone. Example: company.com. ENS records. ns1.company.com. ns2.company.com. So a record, start of authority. The first record in every DNS zone. Contains primary DNS server. Administrator email, stored in DNS format. Serial number. Refresh interval. Retry interval. Expire time. Minimum TTL, or negative caching TTL, depending on implementation. Used for zone transfers and synchronization. PTR record. Reverse lookup. Instead of name. 2. IP. It performs IP. 2. Host name. Example: 192.168.1.10. 2. Server.company.com. Commonly used by email servers, troubleshooting and logging. SRV record. Locates network services. Example: Active Directory. VoIP. Microsoft Teams. SIP. Instead of locating a website, it locates the server offering a particular service. Text record. Stores plain text information. Used for SPF, Sender Policy Framework. DKIM, Domain Keys Identified Mail. Domain Verification. Security Policies. Example. V equals SPF1 include _ SPF.example.com all. Summary of DNS records. A records maps hostname arrow IPv4. AAA maps hostname arrow IPv6. Name points alias to another hostname. MX identifies the mail server. NS records identifies the authoritative name server. SOA records zone authority and configuration. PTR reverse lookup IP to host name. SRV records identifies service location. Text records used for text information, SPF, DKIM, verification, etc. 5 Forward lookup zone. A forward lookup zone resolves host name. 2. IP address. Example. server1.company.com. 2. 192.168.10.20. This is the most common type of DNS lookup. Reverse lookup zone. Reverse lookup performs IP address. 2. Host name. Example. 192.168.10.20. 2. server1.company.com. Uses PTR records and is valuable for diagnostics, auditing, and some email security checks. Recursive versus authoritative DNS servers. Recursive DNS server. Authoritative DNS server. Recursive DNS server receives client queries. Authoritative DNS server stores official DNS records. Recursive DNS server searches other DNS servers for answers. Authoritative DNS server provides the final answer for its zones. Recursive DNS server may cache responses. Authoritative DNS server does not recursively search for other domains by default. Recursive DNS server used by end users. Authoritative DNS server used by domain owners and DNS administrators. Example. When you type www.openai.com, the recursive resolver asks multiple DNS servers until it reaches the authoritative server for openai.com, which returns the official IP address. Key exam points to remember. DNS translates domain names to IP addresses. A records map names to IPv4 addresses, AAA records map names to IPv6 addresses. MX records direct email to mail servers. Name records create aliases for host names. NS records identify authoritative name servers. SOA records define essential information about a DNS zone. PTR records perform reverse lookups, IP to host name. SRV records help clients locate specific network services. Text records commonly support email authentication, SPF/DKIM, and domain verification. Forward lookup zones resolve names to IP addresses, reverse lookup zones resolve IP addresses to names. Recursive DNS servers perform lookups for clients, while authoritative DNS servers provide the definitive DNS records for the zones they manage.